Imagine this. A rocket launches into the sky with a roar that shakes the Earth. Moments later, instead of crashing or burning up in the atmosphere, it calmly returns to land vertically on a small floating platform in the middle of the ocean, as if it never left. Sounds like a sci-fi movie, right? But this is SpaceX reality. This is what just happened for the 450th time. A milestone so massive that it's changing how we view space travel forever. And if you thought this was just another rocket launch, think again. This is history in motion. The Falcon rocket has become a legend. Once dismissed as a risky experiment, today it is the backbone of modern space missions. When SpaceX was first testing these landings, many in the aerospace community were skeptical. Rockets weren't supposed to land and be reused like airplanes. But Elon Musk and his team at SpaceX had a different vision. They wanted to make space travel more affordable, frequent, and sustainable. And now, with 450 landings under their belt, they've proven it's not only possible, it's reliable. Falcon has changed the rules of the game. This 450th landing wasn't just a number. It was a symbol of precision, endurance, and relentless innovation. The rocket lifted off from Cape Canaveral carrying a payload of satellites destined to improve global communication and weather monitoring. As it reached orbit, the booster stage detached and flipped around. Then, using nothing but onboard sensors and advanced algorithms, it guided itself back down through Earth's atmosphere. Within minutes, it landed with pinpoint accuracy on a drone ship named Of Course I Still Love You. And yes, that's the actual name of the ship. This wasn't a soft touchdown on a field. It was a rocket hitting a floating target in the ocean, traveling at thousands of kilometers per hour, dealing with wind, waves, and fire. And yet, it landed gracefully, like a gymnast sticking a perfect landing. That level of control is what makes SpaceX unique. They're not just launching rockets, they're catching them. And they've done it 450 times now. No other company, not even NASA or the European Space Agency, has come close to this level of reuse and efficiency. The importance of this achievement can't be overstated. Every rocket that lands and gets reused saves tens of millions of dollars. Instead of building a brand new rocket for every launch, SpaceX refurbishes and relaunches them, cutting costs and increasing frequency. That's how they've managed to dominate the commercial space sector. Whether it's launching Starlink satellites, carrying cargo to the International Space Station, or sending astronauts to orbit, SpaceX has become the go-to provider. And it all hinges on this ability to land and reuse Falcon boosters reliably. This 450th landing wasn't just a celebration for engineers and space nerds, it was a moment for humanity. A proof that we're entering a new era of space exploration. An era where launching into orbit is no longer a rare, once-in-a-decade event, but something that happens every week or even every few days. This kind of frequency would have been unthinkable just 20 years ago. But now, because of Falcon and its repeated success, it's becoming routine. That routine is what will make moon bases and Mars colonies possible in our lifetime. But how does Falcon actually land? The secret lies in its design. The rocket is equipped with grid fins that pop out like mechanical wings. These help steer the rocket during its supersonic descent. It also has tiny cold gas thrusters that nudge it into the right orientation. And then, at the very last moment, it fires its main engines to slow down and land vertically. It's all automated, there's no joystick or manual control. The rocket is essentially flying itself home, using real-time data and onboard software that's constantly learning and improving. Each landing is a massive ballet of physics, timing, and technology. If anything is even slightly off, wind speed, temperature, fuel flow, the rocket could crash. But SpaceX has refined the process over years of trial and error. Remember, their first few landings were explosions. They called them rapid unscheduled disassemblies. But they learned from each failure, adjusted, improved, and eventually started nailing landings with stunning regularity. Now it's gotten to the point where a successful landing is expected. That's how far they've come. That's how fast they've evolved. And the booster from the 450th landing? It's already being prepared for its next mission. SpaceX doesn't just celebrate and store these rockets in museums. They roll them back into the hangar, inspect them, replace worn-out parts, and relaunch. Some Falcon boosters have flown 15 times or more. Think about that. Rockets that were once single-use, disposable technology are now flying multiple missions. That's not just progress, it's a revolution. It's what will make human life on Mars financially and logistically feasible in the decades to come. Let's not forget the role of the drone ships. These robotic landing pads float in the middle of the Atlantic or Pacific Ocean, waiting patiently for Falcon to return. They're equipped with cameras, sensors, and powerful engines to hold position even in rough seas. The drone ship used in this latest landing has witnessed dozens of touchdowns. It's become part of the story, like a silent partner in this cosmic ballet. Without these platforms, many landings wouldn't be possible. They're as much a part of the success as the rockets themselves. The celebration didn't just happen at SpaceX HQ. Fans, amateur astronomers, and space enthusiasts around the world tuned in to watch the livestream. Social media exploded with praise and awe. Kids in classrooms watched in real time, inspired by the sight of a rocket flying back from the edge of space and landing like something out of a superhero movie. These moments are planting seeds. Seeds that will grow into the next generation of engineers, scientists, and explorers. With every landing, SpaceX isn't just breaking records, they're building dreams. The 450th landing also marks a point of reflection. How far have we come since the early days of spaceflight? The Apollo missions were incredible, no doubt. But they were also costly, dangerous, and ultimately unsustainable. SpaceX has taken the lessons of the past and fused them with modern technology, AI, and a Silicon Valley-style approach to innovation. The result is a space program that's faster, cheaper, and smarter. One that doesn't rely on government funding alone, but on contracts, commercial services, and private investment. It's the new space age, and SpaceX is leading it. There's also the global impact. SpaceX's success is pushing other countries and companies to innovate. China, India, Europe, all are now investing more heavily in reusable rockets. It's created a kind of positive space race. Not about dominance, but about capability. About who can launch faster, cheaper, and more safely. That competition drives progress. It means better satellites for weather forecasting, faster internet via constellations like Starlink, and quicker delivery of scientific instruments to orbit. The ripple effect of Falcon's repeated success touches every corner of our technological world. And still, SpaceX isn't slowing down. With Starship on the horizon, a rocket designed to carry 100 people to Mars, the Falcon program is setting the stage. Everything they've learned from 450 landings is feeding into the next generation of spacecraft. Starship will be bigger, more powerful, and even more reusable. But without Falcon's success, it wouldn't be possible. It's the Falcon legacy that's paving the way for interplanetary travel. That's why each landing, even the 450th, matters. It's one more step toward that ultimate goal. And yet, what James Webb revealed next turned out to be even more astonishing. As the telescope sensors remained locked on the system, scientists noticed small but consistent pulses of radiation emanating from the now unstable star. At first glance, these pulses seemed like typical solar activity, random bursts of energy often seen in many aging stars. But with closer analysis, something far stranger came into focus. The pulses weren't chaotic. They were methodical, spaced at nearly perfect intervals, almost like a ticking clock. It was as though the star had developed a rhythm, a heartbeat, throbbing with the aftershock of what had just occurred. This eerie consistency defied typical stellar behavior. Stars, especially ones recently jolted by such catastrophic events, are expected to fluctuate wildly, but this pattern hinted at something deeper, a possible internal oscillation or feedback loop triggered by the ingestion of the planet. The idea sent shivers through the astronomical community. Was the star echoing the memory of the world it had consumed? Researchers began theorizing that the massive influx of mass from the destroyed planet had destabilized the star's equilibrium. It was no longer in a passive state, it had been shaken awake. The infalling debris, now part of the star's outer envelope, might have caused shockwaves that rippled through its internal layers, triggering a series of complex nuclear and magnetic reactions. These reactions, while not fully understood yet, could be behind the rhythmic pulsations. Some even likened it to a stellar trauma response, as if the star were physically remembering what had occurred, with each pulse a silent cry across the void. This was no longer just a case of a planet being destroyed, it was a system-wide metamorphosis, and the star itself was now behaving like a wounded giant trying to stabilize its shattered balance. But that wasn't the only anomaly unfolding. As data streamed in, another pattern emerged, subtle but undeniable shifts in the star's spectrum. These were not random noise or fluctuations due to temperature alone. No, these spectral variations hinted at something much more complex. The star's surface was changing in real time. Minute alterations in wavelength suggested that the outer layers were heating and cooling irregularly, possibly due to the uneven distribution of new material absorbed from the planet. This meant parts of the star were momentarily becoming hotter or cooler than others, creating spectral fingerprints never seen before. Some regions of the photosphere seemed to be emitting higher energy photons, while others dimmed unexpectedly. Scientists speculated that this could be the result of exotic elements being dredged up from within. Elements that had previously settled deep inside the star but were now being stirred and exposed due to the turbulence. This stirring of the stellar interior raised an even more startling possibility. If deep-layer material was being mixed with the outer layers, nuclear reactions that typically remain isolated in a star's core might be initiating closer to the surface. This unusual activity could result in brief episodes of enhanced fusion, altering the luminosity and chemical makeup of the star. Such fusion surges are rare and usually seen in stars nearing the end of their life, not in relatively stable ones like this. If confirmed, it would mean the planet's destruction had fundamentally changed the star's internal dynamics, possibly aging it prematurely or pushing it into a new evolutionary phase. The idea that a single planet could rewrite the future of an entire star sent shockwaves through the scientific community. Meanwhile, as if the chaos within the star weren't enough, the surrounding planetary system was thrown into a state of disarray. One of the smaller surviving planets, previously on a stable orbit, began to exhibit strange behavior. Subtle changes in its orbital trajectory were recorded, fractions of degrees, but enough to be concerning. Such a shift wasn't random. It suggested that the gravitational balance of the entire system had been altered, likely due to the disappearance of the destroyed planet and the redistribution of its mass. Like dancers reacting to the collapse of a partner, the remaining celestial bodies were adjusting their movements to a new gravitational choreography. Moons around other planets showed wobbling behaviors, while asteroid belts began dispersing unevenly, with some objects being flung inward toward the star and others escaping to the fringes of the system. It was as if the cosmic stage had been rebalanced mid-performance, and now every actor had to find their footing again. But there was more. Much more. Instruments aboard JWST detected expanding clouds of dust and vaporized material, trails of exotic matter once locked deep within the consumed planet. These clouds were not just random debris, they were chemically rich, glowing faintly under the influence of the star's radiation. Spectral analysis revealed the presence of heavy elements like magnesium, iron, nickel, and even rare earth metals. Materials typically buried deep inside rocky planets, now scattered freely across the cosmos. What made this so profound was that these dust clouds were beginning to drift outward, spreading like seeds on a galactic wind. Radiation pressure and solar wind carried them beyond the immediate aftermath zone, sending the ashes of the destroyed world into the wider universe. This was cosmic recycling in its rawest form, a planetary autopsy whose remains could one day become the building blocks of new worlds. Some of the compounds detected were particularly strange. There were hints of silicates fused with complex carbon chains, substances that don't easily form under typical planetary or stellar conditions. This led to a flurry of hypotheses. Could the intense heat and pressure from the planet's destruction have forged these compounds? Or were they relics of ancient geological processes, now exposed for the first time? Either way, their presence was a reminder that even in death, the planet had something to teach us. Its destruction wasn't the end, it was the beginning of a new cycle, possibly influencing the formation of future stars, moons, or even life-bearing planets elsewhere. Like cosmic pollen, these fragments could one day fertilize distant regions of space. Then came the most haunting realization. As astronomers cross-referenced these findings with archival data from older infrared missions, Spitzer, WISE, and others, they began to notice strange similarities. Some of the noise, flickers, and anomalies once dismissed as instrumentation errors now took on a new light. These might not have been glitches at all. Perhaps, scattered across the galaxy, we had already witnessed the deaths of other planets, quiet, unrecognized events hidden in the noise. The difference now was JWST's precision. Its sensitivity turned faint whispers into clear voices, and in doing so rewrote our understanding of past data. Suddenly, we weren't just witnessing an isolated tragedy, we were uncovering a cosmic pattern. This led to a sobering but thrilling possibility. Planetary destruction might be more common than we ever realized. Maybe our galaxy is filled with stars that have feasted on their children, each event leaving behind a unique signature, a spectral eulogy written in light and dust. With this newfound awareness, every past observation had to be reevaluated. Those dimming stars, those unexpected chemical spikes, those strange light curves, perhaps they were silent cries from systems undergoing similar collapses. And with James Webb's continuing mission, we now have the tools to decode those cries, to map the galactic graveyard hidden in plain sight. All of this insight, from a single planetary death. A world obliterated, and yet in its demise, it revealed a universe far more dynamic and violent than we had imagined. The star, once just another point of light, had become a narrator of cosmic change. The debris, once thought to be meaningless destruction, turned out to be clues to deeper processes shaping galaxies. The pulses, the spectrum shifts, the orbit anomalies, all wove together into a story not of loss, but of transformation. The tragedy became a teacher, a cosmic lesson in death, rebirth, and interstellar evolution. And somewhere, deep within that drifting dust, perhaps the echoes of that planet still linger, waiting to find a new home, a new shape, in the ever-turning wheel of the cosmos. And this is only the beginning. Imagine what we'll learn when we witness this happen again, when another world dies and another star learns to pulse with the memory of its sacrifice.